On example 8, evaluate the following limits. And these are all trig limits, which according to our trig limit laws, we're allowed to directly substitute in as long as the number we're substituting in is part of the domain. So let's look at number 1. The limit as x approaches 0 of tangent of x. Is 0 part of the domain of tangent? Sure, you can take the tangent of 0. So it's basically equal to tangent of 0, which is 0. So on this one in particular, you can either think of, let's say, sine of 0 divided by the cosine of 0, and look at your unit circle, of course, and at 0, you have the point 1 comma 0. So you have, let's say, sine is the 0 that's on top, and then the 1 is on the bottom. I tend to just look at the graph, though, or think of the graph, because that first branch of the tangent graph is centered right there at 0. Anyway, on number 2, the limit as x approaches pi of x times the cosine of x. So this is a combination of things. We have a product rule that's inside here, and individually we can break this thing up. It's perfectly legal because x would exist, and so does cosine, because cosine exists everywhere. All of that to say that we are totally allowed to just directly substitute this in and get pi times the cosine of pi. So on your unit circle, pi over here, cosine is the x value, which is -1. So we have pi times -1, or just simply -pi. I'm not boxing my answers. That's illegal. There we go. And then lastly, we have the limit as x approaches 0 of sine squared of x. So here, it's not just one of the trig functions, it's one of the trig functions squared. So this is the power law that we are basically applying. Thusly, the limit as x approaches 0 of sine x raised to the second power, and we are allowed to do that because 0 is definitely part of the domain of sine. So directly substituting that in, the sine of 0 is 0. All right, so again, it's the same exact one that was right over here that I did right at the beginning. It's the y-coordinate there, which is 0. So I have 0 squared, which pretty much is 0. And you know what? I got a box set. Okay.